Hello students, in this video we are going to discuss about insertion sort. In previous lecture we already discussed about bubble sort and quick sort, and now we are going to discuss about insertion sort. So we will see how insertion sort will work with one numerical example. So here in this insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards in your hands. Uh, that means all of you know about the playing cards. So like that only the insertion sort will work. The array is virtually split into a sorted and unsorted part. Values from the unsorted part are picked and placed in the correct position in the sorted part. Okay. So by playing the cards, so we are arranging in our hand while picking from the right hand side, yeah, from left hand side we will pick from unsorted array, we will pick one card and we will arrange it in a sorted way. So like that this insertion sort also will work. So now I will explain it with the example. Okay, with the numerical example you will see, so you can understand it with very easily. Okay, so here this is the example what I'm going to explain. This is the array 4, 3, 2, 10, 12, 5, 6, 7. Okay, total how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8 elements are there. Okay, so here this is a single dimensional array. So here this is index from 0 to 7, and from 4, 3 to 10, 12, 5, 6, 7. Okay, and so here the array will be divided into two parts, that will be I and J. So I is assumed as a, this is array is called this is unsorted array. Okay, from I to end, and J part is we will assume it is a sorted array. Okay, we will pick from the I side one element. We will pick from I array, and we will arrange it in the J array. We will see and arrange it in the J array. So that's actually will do in this insertion sort. So see here, here I have taken two loops, that is for I is equal to 1 to n, and always j will be less than I. That means from I that is starting from 1 to 7, and j will be 0, 1 I minus 1, that will be 0. Okay, so the loop will start like this. We will compare with the j and key value. Key value means always I value only. That means key we will take the first element of I. Okay, the first element of I array. Okay, so I is starting from one first index 1. So the key value is 3 only. Okay, so we will compare with the j elements. So how many elements are there in j? Now only one element is there because the array is divided like this. Okay, so array is divided like this. How it is divided? This is the whole part is I part. This is I part. Okay, and this is j part. Okay, this is j part. From I part we will pick one element and we will fix it in the j part. Okay, that we are going to look. Okay, so now from we are starting from the third element we are starting, because I is starting from here. So we have started 3, we have taken the 3. Okay, so we will compare it with j, whether j is greater than I or not. Okay, this is the key element. So we'll compare with the key element whether a of j is greater than key. If yes, then we will exchange it. Okay, so if yes, we will exchange it. So here we have exchanged, that is 3 and 4 we have exchanged. Okay, after that I will be incremented. Okay, the I will be incremented. So the I is incremented now. Okay, so here I is starting from 2 to 7. So what will be the I part here? From 2 to 7. What are the j part here? 0 and 1. Okay, here only one element is in j, here two elements are there in j. So we are picking from I, that means we are picking the element from I, we are fixing it in j. Okay, so we are comparing each and every element of j and we will fix it. So according to that. Okay, like here I value, that is called a key value. Okay, so here a of I will be considered as a key, so 2 is your key value. So with the j, we will compare it. Each time we will compare with the j. Okay. So j is equal to I minus 1. That means 2 minus 1. Now it is 1. So we'll compare with the 4. Okay. So 4 is greater than. So fix it with the 2. Exchange these two elements. Okay. So 2 and 4 are exchanged. Okay. So j, still it is not completed. One more element is there. So we'll compare it with 3 also. So 3 and 2. Okay, 3 and 2 also we will compare. So we will also change. 2 is lesser than 3 also. So we'll fix it in first position. So 2, 3, 4 will be in, now in J. Okay. So next I will be incremented. That means I already first processed, second processed, and now I is equal to third. Okay. So the array is splitted like this from 3 to 7 and from 0 to 2. Okay, 0 to 2, this is called j and this is called I. Okay, from ith element, that means from I is starting from 3 now. So I is 10. Okay, the third element is I, a of 3 is array of 3 is equal to 10. So the key value is equal to 10, and this is I and this is your j. Okay, so from each and every element of j we will compare with key value. Okay, so now we'll compare with 4 with 10. Is 4 greater than 10? No. There is no need of placing. So, no need of placing. Again, it is not completely compared. For 3 and 10 also will compare. Nothing will happen. Okay. And 2 and 10 also compared. Okay. Already 2 is lesser than, so nothing will happen. So 10 will be placed here only. It is placed correct at correct position only because these three elements are great less than 10. So no need of exchanging, swapping this. Okay. So the third, now the array will be splitted like this virtually. That is, this is I part and this is j part. Okay, 0, 1, 2, 3 and 4, 5, 6, 7 is the I. So I is starting with 4 now. So the 12 will be the your key value. So we'll compare with all these 4 elements. So 2, 3, 4, 10. All are less than 12. So no need of swapping this. Okay. So no need of swapping this. So we'll stop here. Okay. Next, I will be incremented. The array is split like this now. Okay. This is the I part and this is J part. Okay. So I value is, key value is 5. Okay. So it will be compared with these all 5 elements. So 5 is less than 12 because 12 is greater than 5. So we need to exchange it. Okay. So we are exchanging, and again it is it needs to compare all with all j elements. Okay, so now compare only with 12 and exchange for 5 and 10. Okay, this is also greater than, so it will be swapped. Okay, so the next slide is 5 and 10 also it is swapped. Okay, and here after that this 5 will be compared with 4, no need of swapping, already less than, and 3 and 2, no need of swapping. So the array will be like this: 2, 3, 4, 5, 10, 12, and 6, 7. Okay. So now the array is splitted like this. Huh? So that means this is called I part and this is J part. Okay. This is J part. Okay. So here this I will be, now we will be, the key element is this one. Okay. So now we will check this. For 6 we will check. The next slide I am showing this. So 6 is the key and this is the I part. I is starting from here. Okay. And J is all elements, with all elements we will compare the 6. So 6 is less than 12. So swap it. Okay. And again 6 with 10. Yes, less than 12, less than 10. So swap it. Again check with no need of swapping. 2, 3, 4, 5. The 6 is placed in correct position. Okay. So now the arrays will look like this: 2, 3, 4, 5, 6, 10, 12, 7. Okay. So I will be incremented now. Okay. So what will be the I? This is I part and the whole is J. This whole part will be J. Okay. So J, so I will be compared with all the elements. Okay. This is called the key value, and the 7 will be compared with 12. Okay. 7 is less than 12. So what will happen? 7 and 12. So it will be exchanged. If 7 is compared with 10, S. less than, so it will be exchanged. For 6 5 4 3 2, no need of exchanging. At last I will be incremented, that is I is from 0 to 7 only, the loop will continues, it will stop here. So okay, then it will, the sorted array will be like this, look like this. So here what will be the logic here? Here the I loop will be from 1 to n, that means the last element of the array, it will be. So here key we are taking, that is equal to array of I. Okay, the first element where it is starting, we are taking that key, and j is equal to 1, uh, j I minus 1, that means next to that. If I equal to 1, j will be 0. If I equal to 2, j will be 1, like this, one element less than I. Okay, that is equal to j equal to I minus 1. Okay, so the condition is when we will be compare. So here j is 0 minus 1, that means greater than or equal to 0, because array is starting from 0. So that's why this condition is very necessary. If it is less than, j is less than 0, that means there is no element is here. So that's why if j is greater than or equal to 0, that is if it is in array only, then only we will check. And second condition is if this element is greater than the key value, that means in this array, suppose this is the I array and this is the j array. So in this array, suppose this element is greater than this, then only we will check the condition. Otherwise, suppose here it is 5, we no need of checking it. Okay, if it is 5, no need of checking. 5 is correctly placed here only because 4 is less than 5. So that's why if it is 5, no need of checking. If it is 3 only, less than 4 elements are there, that means then only we will check it. Okay. So here two conditions we will check, that is equal to j is greater than or equal to 0, and is array of j is greater than or equal to greater than key, that means key value, then only we will swap it. Here we are looking just writing the swapping. And here how many j elements are there, the complete elements we need to check. So that's why we need to write j is equal to j minus 1, that means each and every element of j we need to check up to 0. If it is minus j equal to minus 1, it will come out of this loop. Okay, it will come out of this loop. Okay, so this is actually the program logic of insertion sort. Here the array will be divided into two parts, that is equal to I and j. From I part we will pick one element and we will insert in the j array at the correct position. Okay, so that is the actual thing, logic of the this one. Okay, so see here this is here suppose the logically we have divided from 3 to 7. So here we have taken the 10 element. Okay, so we want to fix it in 2 3 4, where it will be fixed, these elements are less than, so no need of fixing, it is in correct position only. Okay, suppose here I am taking the I, that is equal, this is I part and this is j part. So here I am picking the 5 from I part. Okay, so we need to fix it in j, where we will fix it. So it will compare. So 2 3 4, where it will be fixed, it will be fixed in fifth position, that means 4k. After the 4 we will fix it, see how it is fixed. So after 4 it has been fixed. So from the I part, we will pick one element and we will fix it in J. That means this is unsorted array. We will think and J part is a sorted array. So like that insertion sort will work. So I hope you understood this logic. And in the next lecture, we will think about, discuss about selection sort. Okay.